This video goes over sketching polynomials when they are not in factored form. So the first thing that we need to do is to factor to find the x-intercepts. So before we do that, we're going to label a couple other things that we know right away from our function. So let's give it an actual value. We'll say f at x is equal to x cubed plus 3x squared minus 10x minus 24. We know that at the very end of this value right here, this one is our y-intercept. So that is one thing that I know, that my y-intercept is 0 minus 24. The next thing that I'm going to figure out is the degree. So my degree is 3, which I know from this exponent that's on the x. The other thing that I know from that first term is that my leading coefficient is a positive value. Together, these are going to tell me that I have an odd positive function, which means that my end behaviors look like this. Or I can say as x goes to negative infinity, y goes to negative infinity, and as x goes to positive infinity, y also goes to positive infinity. Once I've determined the end behaviors there and the y-intercept, now I'm going to do some more work factoring so that I can figure out my x-intercepts. So the first thing that I need to do is so let's do this here. So for x-intercepts, I'm going to factor. So I want to find a factor first. So I know that all of my possible factors are possible factors of my last term because my a value happens to be a 1. So possible factors of 24, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, and plus or minus 12. I am going to start with 1. So I would say f at 1, I'm going to substitute that into my expression, and I'm going to evaluate that. Looking at that right now, I can see that I would have 1 plus 3 minus 10 minus 24. That is not equal to 0. Then I'm going to move on to f at minus 1. Similarly, if I substitute that back into my original formula right here, my original function, and I put in minus 1, I'm going to get minus 1 plus 3 plus 10 minus 24. That is also not equal to 0. The next one I'm going to try is 2. And again, I am substituting in 2 to those equations. 2 cubed plus 12 minus 20 minus 24. That is also not going to be equal to 0. Okay, I would check that using your calculator if you can't do that mental math. Then I'm going to move on to negative 2. I don't need to try 12 and 8 because those numbers are really big. So again, when I'm finding the factor, I am substituting in to my x in my original equation, and I'm seeing if it's going to equal 0. When I look at this, I can see that I've got minus 8 plus 12, which is 4, plus 20, which is plus 24, take away 24, which is equal to 0, which means that x plus 2 is a factor. Sketching is always tricky because there's a lot to write down. Okay. Once I have found a factor, so that was my step number 1, 2 is now I'm going to do my long division. This can be long division or synthetic division. I'm just trying to take out the factor that I found from my cubic polynomial. I am going to use synthetic division here. So 1, 3, minus 10, minus 24. And I'm going to put my factor out in front. So minus 2. Completing synthetic division gives me 1, minus 2, minus 12, and then minus 20, positive 24. which gives me 0, which means that I have a factor. So then I can say that my polynomial is going to be x plus 2 times, and I'm writing it below just because I'm out of space here, x squared plus x minus 12, which comes from my answer to synthetic division. It is not fully factored, so I can factor that quadratic. X plus 2 times x plus 3, x minus 4. These are the values that give me my x-intercepts. So now I can put on my x-intercepts as minus 2, minus 3, and positive 4. My y-intercept I already know is minus 24 down here. All those roots have multiplicity 1, and it's an odd positive, so I can see my end behaviors. Okay. So let's try one more example on the video, and the rest we will do in class. Here is the second one. It's also a cubic polynomial. First thing I'm going to find is my y-intercept. I'm going to use the last value. Oh, I should define it as a function too. So we're going to say my function is x cubed plus 7x squared plus 11x plus 5. So my y-intercept is just that last value. Then I'm going to find my end behaviors by checking my degree, which is 3, and my leading coefficient, which is positive. Those two together mean that as x approaches negative infinity, y also approaches negative infinity, and as x approaches positive infinity, y approaches positive infinity. It looks like this on a graph, exactly the same actually as the first example. Then we are going to find our x-intercepts by factoring. So the first thing that I need to do is I'm going to find a factor. Remember that my possible factors are only the possible factors of the last term. So plus or minus 1 or plus or minus 5. Not a lot of options here. I'm going to start with f at 1. I'm substituting it into my function here. And then I'm going to evaluate and see if it is equal to 0. In this case, it is not 0. Doesn't really matter what number it is. All I'm checking to see is if it's 0 or not. The next number that I'm going to check in is minus 1. If I substitute those values in, I've got 7 times minus 1 squared plus 11 times minus 1 plus 5. This is equal to 0, which means that x plus 1 is a factor. Once I've done that, I'm going to go back up here on the right side again. Now I'm going to divide. I'm going to use synthetic division again because I have a linear factor. Put my coefficients of my original function across the top and continue on. So minus 1 times 1 is minus 1, gives me 6. Minus 1 times 6 is minus 6. 5 when I add those together, and then I get minus 5 and 0, which is good because it's a factor. Then I will, so I guess this is step 3, I will rewrite f at x in terms of the factors. So I can write f at x as x plus 1, my factor from the beginning, multiplied by the quadratic that I found using synthetic division to divide out the factor. So x squared plus 6x plus 5. Then I'm going to, we'll say step 4 is to finish factoring. So f at x is x plus 1 times x plus, 6x plus 5. So then I've got x plus 1 multiplied by x plus 5 times x plus 1, which I can further simplify to x plus 1 squared times x plus 5, leading me to say that I only have two x-intercepts, minus 1 and minus 5. My root at minus 1 has a multiplicity of 2, so I know it behaves like a parabola. I also know that my y-intercept is at 5, and my function's finishing up to the right, and it finishes down to the left. And now I have sketched my cubic function from standard form.